So, according to the internet, the mean length of time for a radio song is 235, and that's seconds. And we want to assume the data follow a normal distribution. And let's say the standard deviation is 45. A, if n equals 4, what would the z-score be for x bar equals 224? And then B, what is the probability of getting a sample mean with a sample size of 4, getting a sample mean that's less than 224? So in part A, we want to, well, the first thing we want to do is probably label what we're given in the problem, right? Very good way to start. So this right here, 235, that's the mean, and that's the population mean in this case, so we'll call that the Greek letter mu. And then we have the Greek letter sigma to represent the amount of variability in the data. All right, now this data is the data regarding x, where x equals the length of a song. X equals the length of a song. So I'll just put x equals song length. And I want to mention this for the following reason. The central limit theorem says that the distribution of x, if that follows a normal distribution, then the sampling distribution of the sample means will be approximately normally distributed with a mean that's equal to the population mean and a spread that's called the standard error equal to the population standard deviation divided by the square root of the sample size. So what we're going to do in this problem is we're going to standardize 224, and then we're just going to find the probability of it. Okay, so part A, and then we also want to make sure we're using this formula. The value that we want to standardize, then you want to subtract the mean and then divide by the spread or the standard deviation. I'll just call it the spread. Right, every z-score formula is going to follow this format. Z equals the value that we want to standardize relative to, that's 224. And then we're going to subtract the mean, which is 235. And then we're going to divide by not just the standard deviation. We got to divide by the standard error, which is going to be the standard deviation divided by the square root of the sample size. That's 45 divided by the square root of 4. And notice that there is going to be less spread in the sampling distribution of sample means than there would be in just the distribution of x. So this z-score equals, well, let's simplify it. In the numerator, we get a negative 11, and in the denominator, we get 22.5. And I'll simplify that to negative 0.49. So that's part A. And then part B says, well, what's the probability of that? And then interpret it. So that's part A. And then part B, which actually finding this probability is not too bad. It's the interpretation that takes a little bit of work. The language can really tangle you up. It just takes some practicing, maybe some verbalizing in front of the mirror or in the car to music. What's the probability that you're going to have a sample of 4 songs on the radio, and the average time for those 4 songs comes out to be less than 224 minutes? That's a very, very, very serious question. We know the true mean is 235. So, would it be crazy for the 4 songs and the average of them was less than 224? I don't know. Let's find out. X bar is less than 224, which is the same thing as, which we just went through the work of dealing with, converting. It's the probability that z is less than negative 0.49, which is an easy probability to find. We're going to go to the standard normal table, and we'll look that up. or we can use the applet, or we can use calculus, or we can use the empirical rule to estimate it, right? A lot of choices, but that's going to be 0.3121. And then the most important part, I think, is compute and interpret. Compute and interpret. Compute, we already did that. Interpret, that's the most important part. Like, in other words, what is this result saying? And I mentioned it a little earlier. I was very passionate about it, in fact. It means the following. The probability of sampling for songs and the mean, I'll say the sample mean, is less than 224 seconds is 0.3121.